Good morning, students. I am Anu Vasudevan, lecturer in Biostatistics Department. I hope all are going well. And this section we will discussing about correlation and regression. We already completed basic concepts of descriptive statistical methods, measures of central tendency and dispersion. We have seen how to summarize a single quantitative variable in terms central tendency and dispersion. Do you know what is quantitative or measurable variables? Age, cholesterol, BP. These are the examples of quantitative variables. And do you know what is measures of central tendency? Mean, median, mode are used for measures of central tendency. Standard deviation, range, variance is used for measures of dispersion. Then, suppose we may have to work on more than one variable at a time. In such situation, apart from computing mean and standard deviation of the two variables, we may be interested to study whether these two variables are correlated or not, and if they are correlated, to study the type and amount of their relationship. For example, the relation between age and BP, and we want to know the relationship or association between age and eyesight. These are some correlated variables. Then, what is correlation? Do you know what is correlation? Correlation is a statistical tool that helps to measure and analyze the degree of relationship between two variables. Nature of the variable is continuous or measurable variables. Can you tell the examples of measurable variables or continuous variables? Height, weight, BMI, heart rate. These are examples of measurable variables. Then, the various measures of central tendency, measures of dispersion, skewness and kurtosis describe various characteristics of univariate population, and we can use this method for summarizing the single value of data. Then, correlation is a statistical measure which shows relationship between two or more variables moving in the same or in opposite direction. And correlation indicate that there is some connection between the variables. That is, when two variables move together, we say they are correlated, and it measures the closeness of the relationship. Is said to be positive or negative according as variables relationship are in the same or in opposite directions. Correlation doesn't indicate cause and effect relationship. Do you know what is cause and effect relationship? Yes, does not tell us why and how behind the relationship, but it just say the relationship exists. Causation take a step further than correlation. It says any change in the value of one variable will cause a change in the value of another variable, which means one variable make other to happen. It is also called cause and effect. I think you all are clear with the method of correlation. The next, how to measure the correlation. Any idea about the measures of correlation? Three important statistical tools used to measure correlation. They are scatter diagram, Carl Pearson's coefficient of correlation, and Spearman rank correlation. The Spearman is used for non-parametric data. Then, a scatter diagram visually represents nature of the association without giving any specific numerical values. A numerical measures of linear relationship between two variables is given by Carl Pearson's coefficient of correlation. A relationship is said to be linear if it can be represented by a straight line. The Spearman coefficient of correlation measures the linear association between ranks assigned to individual items according to their attributes. Attributes are those variables which cannot be numerically measured, such as intelligence of pupil, physical appearance, etc. In scatter plot diagram, we plot one variable on the x-axis and other on the y-axis. The scatter diagram is often used to the initial visualization of the data. If the points play on the straight line, then a perfect linear relationship between the variables, we already know that, may be suspected, and if the points are closely clustered around the line, a high degree of the relationship may be inferred. Then, but if the points are widely scattered without clustering around any line or curve, lack of any relation between the variables may be suspected. And, and we can conclude based on the scatter plot. The first one, the variables linear relationship and the high degree of relationship, and the other one lack of any relationship between the variables. And now we can see the scatter diagram. The x-axis shows the one variable and y-axis shows the other variable. And from this diagram, we can say that the observations are scattered, means the correlation of the variables are very less. Then we can see type of correlation. On the basis of the nature of the relationship between the variables, correlation may be positive and negative correlation, simple, partial or multiple correlation. This section we will discussing about positive and negative correlation. The correlation is said to be positive correlation if the values of two variables changing with same direction. Example, height and weight. This is the type of positive correlation. And if both the variables tend to move together in same direction, so that an increasing in the value of one variable is associated with an increasing the value of other variable, and same, the decreasing in the value of one variable is associated with and decreasing in the value of other variable. This type of correlation is to be positive or direct correlation. Age and height of children is the example for the positive correlation. In the case of negative correlation, is said to be negative correlation when the value of variable change with opposite direction. if the two variables tend to move together in opposite direction, so that increase or decrease in the value of one variable is associated with decrease or an increase in the value of other variables. Correlation is said to be negative correlation or inverse correlation. These are the examples for negative correlation: socioeconomic status of the place and the incidence of tuberculosis in that place, age and peak respiratory flow rate in adult aged above 45 years, and the other example, alcohol consumptions and driving ability, and price and quantity demand. These are the examples for negative correlation. Do you understand what is positive and negative correlation? Once again, I tell positive correlation is the value of two variables change with same direction. Suppose variable x increase, y is also increase. The variable x decrease, y is also decrease. The another example, the water consumption and temperature and study time and grade is the positive correlation examples. And the negative correlation is when the value of variable change with opposite direction is the negative correlation. We already told the example. The negative correlation, age and eyesight is the type of negative correlation. And one more thing is independent or unrelated variables. That means if there is no relationship between two variables, they are said to be independent or unrelated variables. Examples: height and intelligence, height and number of cigarette smoking per day in smokers. These are examples for independent relationship. Then, this is the graphical representation of positive correlation, strong positive correlation, and perfect positive correlation. We know that in a scatter plot, a dot represents a single data point, and several data points graphed, we can see a visual distribution of the data. Depending on how tightly the points cluster together, we can able to find out a clear movement of data. The closer the data points come to forming a straight line when plotted, the higher the concentration between two variables, or the two variables shows perfect relationship. This is the perfect positive correlation because the points come to forming a straight line, and if the data points make a straight line going from near the origin out to high y values, the variables are said to have a positive correlation. Then this figure shows the negative correlation. In the negative correlation, the data points start at high y values on the y-axis and progress down to low values. From these pictures, we can see perfect, strong and negative correlation. Then, the another important component to a scatter plot is the strength of the relationship between two variables. The slope provides information on the strength of the relationship. We know that the strongest linear relationship occurs when the slope is 1. This means that when one variable increases by 1, the other variable also increases by the same amount. This is the linear relationship. The next one, no correlation. From the figure, we can see the data points look scattered. If there seem to be no pattern and the points look scattered, then it is no correlation. Means in which the points do not have a linear trend, means either positive or negative, is called zero correlation. Then this is the one example for correlation. Here the two variables are weight and systolic blood pressure. We can see the 10 patients' weight and corresponding systolic blood pressure. They are 67 and corresponding blood pressure 120, and the next 69 and corresponding 125 is the blood pressure, and the next 85 and corresponding SBP is 140. Then 83 160 is the corresponding blood pressure. 74 and 130 is the corresponding blood pressure. 81 the corresponding blood pressure is 180. Then 97 150, 92 140, and 114 the corresponding blood pressure is 200. The last one 85 the corresponding blood pressure is 130. Here we just want to test any correlation, any relationship between the two variables SBP and weight. Then this scatter diagram shows the variable SBP and weight shows the positive correlation, strong positive correlation, because the data points come to forming approximately a straight line when this plotted. Then I hope you all are clear with this topic's correlation, type of correlation, positive correlation and negative correlation, and scatter plot. The next we will discuss Pearson correlation coefficient. It is a measure of degree of relationship between two variables x and y. Then this section we will discuss in next class. And if anybody have any doubt regarding this section, you can directly contact me. Thank you.